Hey everyone, here's our math problem for today. This is an application of Viviani's theorem. Let's begin with this equilateral triangle ABC with a side length of S units. Then let's locate any point in the interior part of the triangle and let's call this point as point O. Then from point O, let's construct line segment OD that is perpendicular to side AB, representing the distance of point O to side AB, and repeat the process to the other three sides of this triangle. It is given that the distance OD is 2 units, the distance OE is 3 units, and distance OF is 4 units. We would like to find what is the area of triangle ABC. You can pause the video and see if you can solve this math problem. Now let's solve this problem together by first deriving the Viviani's theorem. We're going to replace these distances 2, 3, and 4 with variables x, y, and z and derive the formula. We begin by identifying this triangle AOB. The area of this triangle is equal to 1/2 its base. In this case, the base is S units and the height is X units. Similarly, for triangle BOC, its area is computed as 1/2 times the base times the height, where its base is S units again, and its height is Y units. And for triangle AOC, its area is 1/2 times its base, that is S units, and its height is Z units. Now the sum of all these three areas would represent the total area of triangle ABC. So the area now of triangle ABC is 1/2 SX plus 1/2 SY plus 1/2 SZ, which is basically the sum of these three areas. Notice that there is a common factor of 1/2 S common to all these three terms. So let's factor out 1/2 S. And so dividing each of the terms by the common factor 1/2 S, we now arrive at 1/2 S times the quantity X plus Y plus Z. Let's recall that the formula for the area of a triangle is 1/2 times the base times the height. We have here 1/2, similar to this. This S is the length of the base, which is this part of the formula. This implies that X plus Y plus Z is the height of triangle ABC. And that is now what we call as the Viviani's theorem. The Viviani's theorem says that in an equilateral triangle, the sum of the distances from an arbitrary point to the three sides is always constant and equal to the height of the triangle. And that is what we notice in this triangle. The height, h, is equal to the sum of the distances x plus y plus z. And that is now this part. So putting this together, we know that the area of triangle ABC is equal to 1/2 times the base times the height. And we know that the base is S, and its height therefore corresponds to X plus Y plus Z. So far, we now know what is the value of H in our given problem. That is just the sum of 2 plus 3 plus 4 based on Viviani's formula. We know the height, we do not know the length of the side. So we cannot find the area of triangle ABC yet. But that is not a problem because we have here a right triangle. This line segment AG, which is the height of the triangle, is perpendicular to the opposite side BC, and it bisects that opposite side, which means that in this right triangle ABG, the hypotenuse is S units, the height is H, and the base BG is 1/2 S. So using now the Pythagorean formula, we can now form this equation. The square of the hypotenuse is equal to the sum of the squares of the two legs with a measure of S over 2 and H, where H is now equal to 9. That's why we have this 9. Simplifying, the quantity S over 2 squared is equal to S squared over 4. 9 squared is 81. Multiply each of the terms by 4 to eliminate the denominator, and subtract S squared from both sides of the equation to arrive at 3S squared equals 324, and dividing both sides by 3, S squared equals 108, and take the principal square root of both sides because we are after the length of the side here. So S is equal to positive 6 times the square root of 3. This is now the length of the base. And our objective in this problem is to find the area of triangle ABC. So to find now the area of triangle ABC, area is equal to 1/2 times the base times the height. We now know that the base is 6 square root of 3 and the height is 9. So substituting those values, we have 1/2 times 6 square root of 3 times 9. 1/2 of 6 is 3 times 9 is 27 and copy square root of 3. The area now of triangle ABC is 27 square root of 3 square units, and this problem is now solved.